What's that mean?
Like something that changes, like something that changes something.
Yeah. It's like there a certain circumstance kind of thing, right? So conditional probability is the probability an event will occur given that an event has already occurred. Okay, like our weather has been so freaky this winter, right? So if we wanted to find the probability that it's going to snow in the morning and then be 80 in the afternoon, which it seems like it's been doing, that's a conditional probability. If we're going to find the event that it's 80 in the afternoon, given that it snowed in the morning, kind of thing. All right? Okay. So we go back to independent and dependent again. Same kind of thing. If it's independent, it does not affect. So an independent is when an event that has already occurred does not affect the probability of the new event. Okay, so the weather example is a perfect example of an independent. If it snows in the morning, it's freaky, but it has nothing to do with whether, I mean, the probability of whether it's 80 degrees in the afternoon has nothing to do with whether it's snowing in the morning, right? I mean, it's just random.
What's it supposed to be tonight? Speaking of temperature.
No clue. Yeah, I was going to say, I think it was only going to be like a high of 40 today. Do you have a game tonight? Yeah. It's going to be cold. Okay. If you're finding the probability, so basically what this says is find the probability of A given B occurs. Okay? So if A is that it's going to snow and B is that it's going to be 80 degrees, okay? You want to say, I want to find the probability of A given that it's going to be 80. Well, all you do for conditional probability is find the one that you're looking for because the other one has no effect on it. All right? So if I want to find the probability that it's going to be 80 degrees given that it snowed, whether it snowed, it doesn't have any effect. So all I have to do is find the probability of B. Does that make sense? Okay. Then dependent is when an event that has occurred does affect the probability of the new. Okay, so if I want the probability of A given B, okay, then I find the probability of A and B. And how do we find the probability of A and B? If it was an and, what do? Multiply. Beautiful. Okay? So you find the probability of A and B, so you find the probability, so that's like saying the probability of A times by the probability of B. And then you, I'm sorry, that's probability of B given A. So you take out those duplicates because we're talking dependent. And then you divide by the probability of B. This will look better once we do some examples. Okay? So one of the key things when you're doing the probability of A and B, and it's, or things to keep watch of, is that you're going to find your A times the B, but then you divide by the second one in the formula. Notice how I'm dividing by the probability of B, because that's given that dependent one.
What does that say?
What does what say?
About the P and B. It says P A.
The P of A times the P of B given A. That's the formula for the dependent and. Okay? So on this one, we're saying to find the probability of B given A, so I'm dividing by the A. Okay? So, does that make sense, kind of? Good? Yes? Good on that, Tyler? Just can't read my sloppy handwriting. What's up with that? All right, so let's do some independent examples first. All right? I want the probability of a red cube and a white cube, numbered 1 through 6, both landing on 3, if we know that the white cube landed on 3. Okay? So basically, put your phones away, please. So basically, I'm rolling the die twice, right? Okay, so I'm going to say I want the probability, and I'm doing the white cube. So the probability of a red, given that I rolled the white, and they're both leaning on 3. So for an independent, it doesn't affect the probability of the new event, so I just find the probability of the one. So what's the probability of the white cube landing on 3? Well, I only have 1 3, and I have 6 sides. Good. The hardest part about the conditional with the independence is that it's talking about 2 things, and so you think you have to like multiply them together, and you're just finding the probability of the one. All right, so what's the probability of both cubes landing on odd numbers if you know that the white cube landed on a 3? Well, that white cube landing on a 3 has nothing to do with whether I'm going to roll an odd number or not the second time, right? So that means I just find the probability of the odds, which is going to be 3 over 6, which is just the 1/2 and 50%. Does that make sense? Okay. What's the probability of a penny, a dime, and a quarter all landing on tails if you know the quarter and nickel landed on tails? Does the quarter and nickel landing on tails going to affect whether or not that dime lands on tails or not? No. So I just have to find, I got 1 tail out of 2 choices, heads and tails. So what's the probability of all 3 coins landing on tails if you know the quarter lands on tails? All right, so if I throw the quarter, it lands on tails, that's good, it already happened. What about the dime? I would have a 1 out of 2 shot on that one, right? That would be my probability. What about the nickel? I'd have a 1 out of 2 because I'm going for all 3, right? So is that an and or? That's an and. I need the nickel and the dime to land on the tails. And when it's an and, what happens? You multiply, right? Which is going to give you 1/4 or 25%. Does that make sense? What questions do you have on those? No? Good? All right, dependence. All right, I've got a poll. They were asked for, against, or no opinion about a proposal to increase funding for the school's football program. Okay? So what's the probability a random selected student would be for the proposal given that the student was a girl? Okay? Now, the nice thing about charts is that you can kind of look at, this is an kind of like an and situation. So they're 4 and they're a girl. And so that means that we have a total of 10, right? But this is where it's different from the charts before. Since it's that she's given the student was a girl, that means we have to have taken out a girl the first time around, right? So that means I use only my girl totals. And so that gives me a 10 out of 45, which is 22.2%. Okay, so now if we look at for a boy, I'm going to look in the boys column that the randomly selection was a boy given the student was for the proposal. Okay, so I have 40 boys that were for it, and since it was given the student was for the proposal, I use the for proposal total, which is going to give me 80%. Okay, now I want randomly selected student would have no opinion given the student was a boy. What would be, which one would be my top number?
10.
Yep, I'm going to go with the 10. I like that because that was no opinion for the boys. What's my total going to be? Peyton? 55, absolutely. Because I'm going for the boy total. Perfect. Which gives me 18.2%. All right, let's try this with a Venn diagram. All right, so we have a Venn diagram. A is the number of 10th graders. B is the number of high school students that have a computer. All right? So, I want to skip to number 9 first, because I think that helps to explain it first before we find what does this symbol mean. I'm finding the probability of what? But what is A given B? Tenth graded, given they have a computer. Perfect. Oops, they have a computer. Does everybody agree with that one? Okay. So, that means that when I find my probability of A given B, what's going to be my top number? What are my 10th graders that have a computer? 15, because they have to be in both circles, right? They have to be a 10th grader, but they have to be a computer. Perfect. And what's my total going to be? 45 have a computer, but what about my 15? They have a computer too, right? So that means I would have a total of 60. Would you agree with that? Which gives me 25%. Because thinking about it, how many 10th graders do I have total? I'm going to have 35 total, right? 35 10th graders. And then I'm going to have 60 with computers. Does that make sense? Okay, so let's now find the probability that they have a computer given they're a 10th grader. So now I'm going to have B over A, agreed? So now I still have 15 that are both, but now it's given that they're a 10th grader. What's my total this time? 35, perfect, which is 42.9%. Okay? All right, we have, 15, 20 minutes to work on the practice problems.